Hello everyone. Have you wondered how your message travels from your phone to your friend's device in just a second? Well, that's where the OSI model comes in. In this video, we'll understand how data moves through a network using the 7 layers of the OSI model step by step. First, let me know let me tell you about our 7 layers. First, physical layer that deals with the physical connection and data transmission. Second, data link layer handles error detection and framing. Third, network layer, responsible for routing and addressing. Fourth, transport layer, ensures reliable data delivery and the sequencing. Fifth, session layer, manages sessions or connection between systems. Sixth, presentation layer, translates, encrypts, and compresses the data. Seventh, application layer, provides services for end users like browsers, emails, apps. Let's move on to the simulation. 5 elements. The first one is PC. PC are hosts that are smart devices and which are the start and end of communication, and they run applications like a web browser, HTTP, email client SMTP, or a file server like FTP and SMB, which all operate at 7 layer. And the second is switch. Switch is on the layer 2, which is data link layer. So a standard switch job is to forward data within a single network, that is a LAN. It makes a decision based on MAC address. So in Packet Tracer, a switch maintains a MAC address table to learn which device is connected to which port. When a PC sends a message, an Ethernet frame, the switch looks at the destination MAC address in the frame's header. Let's move on to router. Router is on the layer 3, that is network layer. A router's job is to connect different networks and forward packets between them. For example, connecting your home network to the internet. It makes a decision based on IP address. Another one is switch. It is same as the first one. Let's move on to the server part. Server part is same as the PC part. They are also smart devices, which are the end of communication, where we called it a destination part. Same here, it runs applications like a web browser, email client, and file server. Let's move on to the server. First we start for simulation. We have to click on server. As you can see, there a page open. Let's move to the IP configuration. Here you can see there are URLs. You have to copy the first URL. Now you have copied the URL. Move on to the reset simulation and go to the PCPT. If you click on it, there is a page open. Then move on to the web browser. When you click on it, there's a page open. Paste your IP address here and press go. You should see there's a changes packet form on a, as you can see here a UDP packet had formed. Now if we click on it, we see all 7 layers. So as you can see, the layer 7 is our application layer where it provides the user like browser and email apps. And the layer 6, that is a presentation layer where the data encrypts and compresses to form a packet from data. And then you can see layer 5, session layer, that manages a connection between system. And you can see layer 4, there are TCP, transfer control protocol, where source port 1027 and destination port is 80. And layer 3, that is a network layer. So you see layer 3, that is our network layer, which is responsible for routing addressing. So as you can see, there IP header where source address and destination address is there. Let's move on to the second layer. That is our data link layer, which mainly works for the error detection and framing part. So as you see, the packets have formed to the frame and the framing has done. And let's move on to the layer 1, that is physical layer, that deals with the physical connection and data transmission. So there are ports converted. Let's see how packets transfer through each layer. As you can see, so from 765 layer is combined and directly moves to the transport layer. And then it's moved to the layer 3. And then it's moved to the layer 2. Now the last layer 1. Let's run the UDP packet. The simulation part. From the right side, you can see a simulation window where the play button is there. If you click on the play button, the packet will move on from PC to switch. Let's click on the packet.
As you can see, the switch contains two layers only, the physical layer and a data link layer. And let's click on the next layer. If you click the next layer of data link, now as you see, let's click on the play button. Now from packets move from switch 0 to router. If you click on the packets now, you will show three layers. The third layer now added, that is network layer, where header source address and destination address is there. Let's click on the next layer. As you can see, the packets move from layer 1 to layer 2 and then layer 3. The loop will go through the same, now 3 to layer 2 and then layer 1. The router works is done. Now as you see, the packets now moving from router to switch 1. If you click on switch again, there you will see two layers, layer 1, layer 2. The loop will goes from 1 to 2 and 2 to 1. Now we start a simulation. Now switch 1 to server, or packets move on from switch 1 to server. Let's click on this packet again.
यहाँ पे जो बता रहे हैं ना switch one, as you can see.
Okay, now packets will move from switch 1 to server. Click on the play button. You can see the packet have moved from switch 1 to server. So now we have to click on the packets. As you can see, currently we are on the first layer, that is the physical layer. If we move to the second layer, it is where error detection and framing happen. We move to the third layer, where you can see the IP address of source and destination. The 1.10 is for PC and the 2.10 is for the destination. Moving to the fourth layer, PC, TCP source port, that is 1026, and destination port 80. Now we have seen the layer 3 on the right side, where the IP address has been interchanged. 2.10, which we see in PC's destination, now it's for the PCPT. The destination IP address 1.10, that is previously for PCPT, now at the destination for the server part. Moving to the second layer on the right side, where framing interchange happens, you see that arrow is for interchanging, and now last layer, physical layer, where packets get bound to the frame. Let's move back to the simulation part. Right side, we click on the play button. Now you can see a package move to the server to switch one as an acknowledgement form. Now switch one to router. So it's following the same path. Now router to switch one. The acknowledgement is going to PC part now. Acknowledgement has received. You can see the tick part. It means the acknowledgement has been received. Now, as you can see, previously we were on the right side when we are sending a packet. Currently, now we are receiving the ACK packet here on the left side. As you can see, we are currently on a physical layer. Now say layer 2. Layer 3, you've seen the IP address has been interchanged. Now 2.10 is for the PC part and 1.10 that is for the server part, destination part. And the layer 4 is the same. Source part has been 80 and destination becomes 1026. Now we will start our simulation without any interruption. Let's see how a packet will move. Now we have to reset the simulation. Go on the right side. We will click on the reset simulation. And we will move back to the PC. We have to add packet. Now copy the URL. We have pasted. We can go with this only. If you click on the go, the packet will form. Now we will start our simulation without any interruption. Go on the right side, click on the play button. You can see the packet starts stimulating. Now packet is on switch button. I'll move to the route. And now router to switch one will move. You can see no interruption occurs. The simulation is perfect. Now switch one from server. Now the PC to switch one. First we move to the switch one. The acknowledgement has been received to switch one. Now it moved to router. As you can see, there is no interruption occurs. Now it moves to the switch 0. Then it will move to the final destination, that is our PC. As you can see, the tick mark is for that the acknowledgement has been received successfully. Thank you for watching our video. Hope you have learned something from it. Thank you.